Example 3 says, where do the following lines intersect? And they give you these two lines. 2x minus y equals 4 and 4x plus y equals 9. So once again, first step, just label the lines 1 and 2. Right? The next thing is to solve for one of the variables. Right? Now you can choose to solve it here, you can choose to solve it there, right? Once again, I'm going to choose, actually I'm going to choose this one now. I think, I'm going to try it like this. You can try it maybe the other way, but I'm going to try it this way. So just to show you that it will work, it doesn't matter which one you choose as long as you're consistent. So I'm going to solve for, I'm going to create a new equation too. So y is equal to, and in fact, yeah, I prefer to choose equation 2 simply because the y variable here is positive. This one is negative, so fine. Okay, so 4x, when you move this term to the other side of the equal sign, it becomes negative 4x plus 9. Okay, now we're going to use this to substitute it into equation 1. So let's substitute equation 2, now this equation 2, into 1. So let's do that. So now we take equation 1 is what? 2x minus y. Well, our y is this now, minus 4x. Let's move this up a little more. 4x plus 9, close brackets, equals to 4. Next, let's start simplifying this. So there's a minus in front of the bracket. So what we do here, this becomes positive 4x, this becomes negative 9 equals 4. Now let's start collecting like terms. So 2x plus 4x, that becomes 6x. Negative 9, you move it to the other side, it becomes plus 9. 4 plus 9, that gives us 13. And now let's solve for x. So x will be equal to 13 over 6. And that's it. Let's leave it in fraction form for now. And now what we have to do is same thing as before. We take the x and we substitute it into either 1 or 2 in order to solve for our y coordinate. Okay, so let's start doing that. I'm going to grab another sheet of paper here. Okay, sorry for the short delay, but let's continue doing this. So now we're gonna take, as I said before, right, x equals 13 over 6 into equation 1, and then we're gonna solve for y, right? Solve for y. I don't think I was writing this on the other examples, but I don't think I was writing that on the other examples, but essentially that's what we're doing. Okay, so we take this, we're going to substitute it into equation 1. Our equation 1 is 2x minus y equals 4. So let's start doing that. So we do 2, now x is this, 2x, 13 over 6. 2 times 13 over 6 minus y equals 4. Okay. So now let's start solving this, right? Let's start solving for y. So this becomes 13 over 3, right? When you multiply this times that, that gives you 13 over 3. These cancel out. Half of 2 is 1, half of 6 is 3, so you end up with that. Minus y equals 4. Now let's move the 13 over 3 to the other side of the equal sign. Or in fact, actually, we can move the 4 to this side of the equal sign, then the negative y to the other side, but essentially we're doing the same thing. So we end up with 13 over 3 minus 4 equals y. Right? Now, let's add these two. So, in other words, we have 13 over 3 minus, right? 3 is the lowest common denominator between these two, so 13 over 3 minus, and then so we multiply the denominator here by 3, so whatever we do at the top, we do at the bottom, we do the same thing at the top, so this becomes 4 times 3 becomes 12. So what's 13 minus 12? That gives us 1 over 3, so y equals 1 over 3. So that's our next coordinate. So that means that the point of intersection between these two lines, right, therefore the point of intersection between these two lines is 13 over 6, which was our x coordinate, comma 1 over 3.